Hello everyone, this is Pawan Inania, Assistant Professor in the Department of Electronics and Communication, Government Women Engineering College, Ajmer. In the last lecture, we discussed about the Laplace transform and basic questions of Laplace transform, the properties of Laplace transform and the properties of region of convergence. So it was the session totally dependent on the introduction part of Laplace transform and the basic formulas of Laplace transform. Today we are going to discuss about the inverse Laplace transform. So before going to inverse Laplace transform, one very important question is there. So first of all, let us discuss about this question. If any time domain signal x of t is equal to b e to the power minus b mod of t is applied to any linear time invariant system, then what should be the Laplace transform of this particular input? In this question, there may be two cases. We can see here that b is a constant value. So b may be greater than 0 or b may be less than 0. In the first case, if b is greater than 0, then we can draw this input signal like this. This is the exponential signal in the both direction, negative and positive direction. In the another case, when b is less than 0, then we can draw this signal like this. Okay, if b is less than 0, then let us have some value of if b equal to minus 1, then it will be e to the power plus 1 mod of t. So signal will be like this. Okay, and another case is b greater than 0. If we are taking the value of b equal to plus 2 or plus 3, then it will be e to the power minus 2 or 3 mod of t. So in this question, we can divide this input in two parts because we have mod of t. Mod t means the range of this signal is from minus infinite to infinite. So in the range minus infinite to 0, we can define this signal like this. U of minus t means the left-sided signal. Range is from 0 to minus infinite. And the another part is u of t, in which we can see that e to the power minus bt and u of t means the positive part of this signal, 0 to infinite. So basically this is the linear combination of two signals. We can write e to the power minus bt u of t as x1t and e to the power bt u of minus t as x2t. So this is the combination of x1t and x2t. Since we know that e to the power minus bt ut, as we discussed in the last lecture, that e to the power minus at ut is equal to 1 upon s plus a if it is a right-sided signal, and e to the power minus at u of minus t is equal to minus 1 upon s plus a when it is left-sided signal, u of minus t. Okay. So in this question, we can calculate the Laplace transform of e to the power minus bt u of t. U of t means right hand side signal. So the Laplace transform of this input is equal to 1 upon s plus b. And the ROC, the real part of s, is greater than minus b. Why is greater than minus b? Because this is right-sided signal. And e to the power bt u of minus t is equal to minus 1 upon s minus b, and the ROC is real part of s is less than plus b. Why it is plus b? Because as u of minus t, this signal is left-sided signal, and whenever we solve any left-sided signal, the ROC must be less than the particular pole. So we can draw these two parts. First part is 1 upon s plus b and second part is minus 1 upon s minus b. So there is a pole 1 upon s plus b means pole is 8 s equal to minus b, and in this part pole is 8 s equal to plus b. So we can draw the ROC of this particular signal, that one pole is 8 minus b and second pole is 8 plus b. When b is greater than 0 and when b is less than 0, there are two cases. Okay, so the first case is when b is less than equal to 0. Let b equal to minus 2. If b equal to minus 2, this b equal to minus 2, we can put b equal to minus 2, then it will become plus 2 and it will become minus 2. So the ROC is real part of s is greater than plus 2, this is greater than plus 2 and less than minus 2, this is less than minus 2, when we are assuming the case b equal to minus 2, the first case. Okay, so we can see here that there is no common region in this s plane. Okay, so if there is no common region, then Laplace transform does not converge. Okay, and we cannot calculate the Laplace transform. In the second case, when b is greater than 0, then we can see, let's assume that b equal to plus 1. So put plus 1 here and plus 1 here. So ROC will be s greater than minus 1 and s less than plus 1. This is s greater than minus 1 and s less than plus 1. So we can see the common region in between minus b and plus b. So the Laplace transform can be calculated for this part. Okay, so the final result of this input signal e to the power minus b mod of t is equal to 1 upon s plus b minus 1 upon s minus b is equal to this one, and ROC is in between the minus b and plus b. So the first case b was less than equal to 0, it is not possible. The second case is possible because there is a common region for this input signal. So inverse Laplace transform. Now we are going to discuss about the inverse Laplace transform. X of s, the frequency domain part of the signal, x of s is equal to 1 upon s plus 1 and s plus 2. The ROC is greater than minus 1. In the inverse Laplace transform, the ROC is defined with the equation, that is, real part of s is greater than minus 1. So perform the partial fraction expansion. First of all, we are going to perform the partial fraction. So x of s can be break into two parts, a upon s plus 1 and b upon s plus 2. So you all know about the partial fraction. This is a simple method. A equal to s plus 1 multiplied by x of s when s equal to minus 1. When we solve this expression, s plus 1, 1 upon, this is x of s, this term will be cancelled out, and 1 upon s plus 2, put the value of s equal to minus 1, 1 upon minus 1 plus 2 is equal to 1. Like this, the second part, again by the partial fraction method, we can solve this and the constant b will be equal to minus 1. So finally, the value of a is 1 and the value of b is minus 1. So we can have this expression like this, x of s equal to 1 upon s plus 1 minus 1 upon s plus 2. Okay, so we all know that what is the Laplace transform of e to the power minus t? Constant is 1. Constant is 1 means a equal to 1. When e to the power minus t, the Laplace transform of e to the power minus t is 1 upon s plus 1. And the Laplace transform of e to the power minus 2t is 1 upon s plus 2. Okay? And this minus is because of the value of constant b. Okay. So now we know that the ROC is given is the real part of s is greater than minus 1. Greater than minus 1 means this signal is right-sided signal. Whatever the poles are there, whatever the number of poles are there, but the final ROC is greater than -1. Okay, so this is dependent on the final ROC, that signal is right-sided or signal is left-sided. If signal is right-sided, then the final result will be associated with u of t. So the inverse Laplace transform of 1 upon s plus 1 is e to the power minus t multiplied by u of t, because this signal is right-sided. And in the second part, 1 upon s plus 2, the inverse Laplace transform of this one is e to the power minus 2t multiplied by u of t. Okay, so we have calculated the inverse Laplace transform. Now we can see that there may be some another cases. The first case we have already discussed, when ROC is greater than -1. If the ROC was less than -2, then what will happen? Less than -2 means there are two poles. One is s equal to -1, second is s equal to -2. So there are two poles. These are the poles, -1 and -2. Okay, and always what is ROC? ROC is always the common region. Okay, so in this part the ROC is greater than -1, in this part ROC is greater than -2. If we combine these two poles, then what should be the ROC? The common region. And what is the common region? Common region is greater than -1. Okay, so it was defined that ROC is greater than -1 because of this case. The second case is less than -2. This is less than -2. If ROC was less than -2, means the common region is defined as less than -2, then this case should also be less than -1, -2. Okay, so this is the case. The final ROC is less than -2. Okay, then this ROC must be less than -1. Okay, so that we can find the common region as less than -2. First is less than -2, second is less than -1. Then what should be the common region? That is less than -2. So for this case, ROC is less than -2, that is a left-sided signal, because less than -2 means the negative part, left-sided. The inverse Laplace transform of this 1 upon s plus 1 is e to the power minus t u of minus t. Why this u of minus t? Because of the left in the first lecture. And in the second part, 1 upon s plus 2, the inverse Laplace transform of this 1 upon s plus 2 is e to the power minus 2t. This is the constant value, e to the power minus 2t u of minus t. Why u of minus t? Because this is also the left-sided signal. So finally, we can have the result x of t is equal to minus e to the power minus t plus e to the power minus 2t multiplied by u of minus t. The third case, ROC, the common region is in between -2 and -1. So we can see that if ROC is greater than -2, then it will be assumed as right-sided signal, and when ROC is less than -1, then it will assumed as left-sided signal. ROC is greater than -2 and ROC is greater than -1. One is right-sided and one is left-sided. The common region is in between -2 and -1. So for this part, 1 upon s plus 1, this is 1, pole is at -1. ROC, we can see ROC is less than -1. Less than -1 means left-sided signal. So what is the inverse Laplace transform? E to the power minus t u of minus t, because of the left-sided signal. Second part is here 1 upon s plus 2. This is right-sided signal. So the inverse Laplace transform will be e to the power minus 2t u of t because of the right-sided signal. So it was the inverse Laplace transform. We discussed many cases in this topic, inverse Laplace transform. In the next lecture, we will discuss about the causality and stability of Laplace transform. If you have any type of doubt, then you can ask in the comment box. Thank you so much.